So it's great to have all this data sitting around, whether it's structured or not. But how do we process it? And then, what do we do with it? What's the point of having all the data? In this lesson, you will learn how we can extract knowledge from data to help us answer questions and solve problems. As we've gone through and talked about data and big data, we've discussed the difference between structured and unstructured data. All right, so in the previous activity where you digitized business cards, you had to work to collect structured data from a source which was only semi-structured. All right, now in this lesson, we're going to investigate ways in which structured data may be extracted from a data set that is noisy or completely unstructured. And our example that we're going to use of this is we're going to look at the World Wide Web. Take a few minutes and read below about how the internet is structured. And watch the video about internet search in Google and in the Open Directory project, which is unfortunately now an obsolete type of search, meaning it doesn't exist anymore. So as you do this, you will quickly pick up on the fact that the internet is kind of a mess and it lacks structures, and that some search engines actually provide more structure for data for the search results than others. Okay, so have fun with that. All right, so as you saw in that exercise, Mozilla's approach to organizing data contained on the internet is very labor intensive for people. The alternate approach, which is the indexing and the search, doesn't rely on humans. Okay, so it's pretty interesting, these two things. And again, it's unfortunate that we don't have that Open Directory project as a reference, because they were kind of on their way to trying to figure out a solution to this. I think maybe the problem just got too big. And let's move on and talk about this indexing that you heard about. So of course we use Google and every now and then another search engine, but mostly Google, right, to find things on the web. The question is, how does Google know where all of these pages are located? Because they're stored somewhere physically, right? Web pages are stored on a server somewhere. How does Google know where to go get it from and which of the search results are actually relevant to your query, right, to your search? So Google uses these things, these virtual robots, and they call them spiders, okay, these little spider bots, to index and explore the web. And, you know, that kind of makes sense, right? Because they're crawling around the web, get it? Spider, web, crawling around to obtain information. So, of course, spiders aren't actual robots with, like, you know, moving parts. They're computer programs. And the computer programs actually follow a very simple routine. So the algorithm for a spider bot is to visit a web page, gather all of the links that exist on each of those web pages, and add the links to a list of pages that it's going to visit in the future. All right? And it's going to repeat or iterate through this process until it has visited all of the pages on its list. So it has a fairly simple job. It's just a really extensive job. There's an article you can read as an extension of the first exercise after this lesson that shows you the statistics that you can see on the screen right now. And what should jump out at you is the amount of web traffic that isn't even human. So human traffic accounts for less than 40% of the traffic, as opposed to what you see on the screen there showing 61.5% bots. All right, so that's crazy. All of these little spiders are crawling around the web doing their thing, and we don't even know it. We have no way of really detecting that. Of course, when you fill out information on a form, it has to make sure you're not a bot, right? You have to do the CAPTCHA, and we'll talk about that a little bit more later. But yeah, so now, unfortunately, we even have to prove that we're human because so much web traffic is actually not. Kind of weird, right? If you want to learn a little bit more about spider bots, there's a video below that you can check out to see how these spiders are actually working to create Google's index of the web, which again is just an astonishingly big job, but ultimately it affects your search results. When you search for something, the work of these spider bots affects the results that you get. All right, we're going to look at another data extraction technique. And an example of this, in addition to the spider bots, is something called screen scraping. You may or may not have heard of this. We're going to use this as an example because the need to analyze data is everywhere. Everyone wants access to data so that they can use it for their own specific purposes. And regardless, there's data all over. And sometimes we really want to get our hands on it, but we can't, because it has already been structured for something other than analysis. It's been structured maybe to see on a screen. All right, so we might be talking about text from a book, we might be talking about data from an image or series of image, or even a complete website, right, like the one that you're using right now, or a table or graph or something like that. All right, so this screen scraping is all about converting data that has already been formatted for humans to be able to see and to actually restructure it so that it can be used by a computer in some automated process or a program. In particular, the conversion is usually aimed at taking stuff that's been made for on-screen display and producing some sort of input for a computer, like a file or the clipboard. So I mentioned that word clipboard, and you may or may not be familiar with that. Whenever you copy, you right-click copy, you don't see what you copied until you paste it, right? Well, where did it go? Well, the way Microsoft puts it, they say it's sitting on the clipboard, okay? And then once you decide where you want to put it, then you do your Control-V or your right-click paste to put it there. All right, so that's what we mean by the clipboard. Using the clipboard isn't just for copy and paste. Sometimes we want a screenshot, right? We know all about taking screenshots on our smartphones. You know that if you're on a Windows computer, you can hit the print screen button. You know that if you're on a Mac, it's a Command-Shift-3 to take a screenshot of your whole screen. And you can even do Command-Shift-4 to actually specify the particular part of the screen that you want to take a screenshot of. So we know that we can copy what we see on our computer screen, and we can put it somewhere else. What form does it take? Well, if I screenshot a web page, do I get a web page? If I screenshot text, do I get text? No. We always get an image. Okay, a screenshot is an image. The image might be useful. It depends on what you wanted to use it for, right? But if you look at the example on the slides, you can see that someone has screenshot this description of the book Blown to Bits. All right, they have taken a picture of how this information looked on their computer. And to you reading this, or to someone who was trying to decide if they wanted to read Blown to Bits or not, this is extremely useful. We can read it and make our decision based on what it says. But the question is, can the computer read it? Could I really run a detailed analysis on the text? No, I couldn't. That's a problem. Sometimes we want to access this in a way where we can actually process the data and use it for something. In this particular situation, if we had a series of screenshots and we needed to extract the text, we could use an OCR type of software. All right, and that stands for optical character recognition. So optical meaning visual, and character meaning text. Okay, so being able to visually recognize text as it occurs in pictures. All right, because we know that pictures and text are encoded as two completely different things, and they don't work well together and they don't work at the same time. All right, but if we run this image that we took, this screenshot, through an OCR software, it would be able to pull out ASCII text. All right, so now you've got what you see here. Now I can copy and paste this. I can do a word count, right? I can't do a word count on a picture, but I could do a word count here. I could run spelling and grammar checks. If I wasn't really 100% sure, is that really how you spell unprecedented? Now I can check, right? I can right click and look it up, or long press or whatever. So now I can actually work with this text. That's the use of screen scraping. All right. And you can even, and by you, I mean people, there are people who have written software programs that will take information from a web page and actually not only just return the text, but actually structure the data on the page for you depending on what you're looking for. So maybe if I'm on Amazon's page and I want to look through the reviews for Blown to Bits, I can actually extract the text out of that web page and find all of the 5-star reviews or the 1-star reviews. So that's a pretty useful data collection technique when the data isn't really available to me in the form that I want it. All right, and actually there's a neat video about screen scraping below in the lesson if you would like to learn more about it.